Welcome to qnawire.
So in this problem, we have to give an algebraic solution to the setup because we're not given any numbers. We see what information we have. So we are given the radius of the uniform disks of the yo-yo. So we're given the radius of the disks, and that's R, big R. Then we are given the mass of each disk. So mass of the disk, which is small m. Then we have the axial radius. So axial radius, which is small b. Now we have to find out the linear acceleration and the angular acceleration in terms of these three letters. So let's draw the yo-yo first, and then we can see how to solve the problem. So let's say that's the yo-yo where this red one is the front disk and the green one here is the disk which is at the back, and then we have an axle which is going between, which is connecting these two disks. Now if we have a string that goes to the axle, and let's say it comes out from the yo-yo like that. Now as we can see, due to the string is unwinding, so there's a linear motion involved in this rotational motion problem. So we'll be applying the force equation due to the linear motion, and we'll consider the center of mass of the system. So we'll call it F external, which is equal to mass times ACM. So we'll be applying this linear motion to the string or to the center of mass of the yo-yo, and we'll be applying tau, which is torque, that's equal to ICM times alpha, to the rotational motion of the yo-yo. Now let's first deal with I here. So since it's a uniform disk, so I will be half m r squared. But since there are two disks that are connected together, so we'll add them together. So ICM will be twice of I. So that means we'll add we'll multiply 2 to this. So finally we'll get mr squared. Right. Now for the tension, if we say that the tension is acting this way and we call it T, and the whole system is going downwards, and we know that the downward force is twice m times g, and the reason we have 2 here is because we have two disks with mass m for each disk. So since this is going down overall, and we call, let's say the linear acceleration is a, that means twice mg minus the tension will be equal to twice ma. So that's the linear part of the equation. Let me write down that on the next page as well. So we have 2mg minus t, which is equal to 2ma. And then what about the rotational motion? So for the rotational motion, we have the torque, and if we know that the axle radius is b, so let's say this is the axle, and the torque is the torque will be linear force times the radius. Now for the axle, the radius is given as b, and the linear force is here is tension force. Because of the tension force, this is unwinding. So the torque will be T times B, where B is the radius of the axle, and that's equal to I, or I center of mass in our case. Let's just call it I in our problem so that it's easier to understand. So let's call this one as I1 as in the first one, and let's just call this whole thing I, just so that the problem is easier to visualize. So it's I times alpha, and we know that since it's spinning without slipping, so alpha will be A by R, right? Because so we can substitute this over here. So we'll have A by, sorry, it's going to be B because this yo-yo is rotating on the axle. So this will be B, not R. So yeah, so if we try to eliminate T from these two equations, we'll see that A will be equal to 2mg by 2m plus I by b squared. From here, we can write it a little differently. So it's going to be 2 by 2 plus r b whole squared. And the reason we did that is because we took m outside of this parenthesis, and that's why we had m over here. So this expression, when we took m out, this expression became I by mb squared, and we know that I is mr squared. So I by mb squared became this by mb squared. So we got rid of m's, so we got r over b whole squared, and that's what we wrote here. So this is the final expression for the linear acceleration, and we know that alpha is nothing but a over b, so we just need to multiply, we just need to divide b with this expression to get alpha. So alpha is g times 2 divided by 2 times b plus r squared by b. So now if we want to find the tension in the string, it should be easy. So tension is twice m times g minus a, where we can substitute the a, and the way we do that is we take 2mg outside, then we have 1 minus 2 over 2 plus rb whole squared. And if we simplify this a little bit, we get 2mg divided by twice of b by r whole squared plus 1. Thank you.